2009 second chance. We have a function f defined on 0 plus infinity, a function f defined on 0 plus infinity by fx equals 2x plus 1 e to the minus x. And the domain is 0 plus infinity. And C is its representative curve in an orthonormal system. Calculate the limit as x tends to plus infinity of fx. To calculate the limit as x tends to plus infinity of fx, we replace x by plus infinity. We get 2 into infinity, infinity plus 1 infinity times e to the minus infinity 0. So it is indeterminate. We have to change the form. Then we use Hopital's rule. So 2000. So we have limit as x tends to plus infinity of fx equals, we replace x by infinity as we said. It is equal plus infinity times e to the minus infinity. E to the minus infinity is 0. So infinity times 0 is indeterminate. Change the form. Change the form. We say limit as x tends to plus infinity of fx, limit as x tends to plus infinity. This is e to the minus x. We put it down in the denominator. We change its sign. So can e minus x, it will be e to the x. It will be infinity over infinity by replacing x by infinity. 2 times infinity, infinity, e to the infinity is infinity. So by applying Hopital's rule, we will get limit as x tends to plus infinity, derivative over derivative. Derivative of 2x plus 1 is 2. And derivative of e to the x is e to the x. Limit as x tends to plus infinity. Replacing x by infinity. This here 2 over infinity. E to the infinity is infinity, so 2 over infinity is 0. So x tends to plus infinity, y tends to 0. Therefore, y equal to 0, or the x-axis is a horizontal asymptote. Now, second part, calculate f prime x and set up the table of variations. Now, f prime x. This is fx. It is of the form u dot v. Then f prime x equal u prime. U prime will be equal to, and v prime equals minus e to the minus x. Then we apply the rule f prime x equals u prime v plus v prime u. So this is fx of the form, part 2 now. Fx is of the form u dot v, this is u, this is v. F prime x equal u prime v plus v prime u. U prime is 2 times v e to the minus x plus v prime is minus e to the minus x into 2x plus 1. So it will be e to the minus x common. We take e to the minus x common. 2 minus times 2x minus 2x minus times the plus 1 is minus 1. So we get minus 2x. 2 minus 1 is 1 times e to the minus x. This is f prime x. Now part 3, set up the table of variations of f, table of variations. Before doing the table of variation, we have to study the sign of f prime. E to the minus x is positive, so we study the sign of minus 2x plus 1. Then f prime x equal to 0. To study the sign of the derivative, e to the minus x is positive. We don't take e to the minus x, so we take minus 2x plus 1 equal to 0. Then minus 2x equal minus 1, x equal half. It is an accepted value. It is belong to the domain 0 plus infinity. So table of variations, we put x, domain is 0 plus infinity. This is the domain. And the value at which the derivative is 0, at x equal half, the derivative is 0. Now to know the sign in this interval, I take number 1. If we determine f prime of 1, f prime of 1 will be equals, we replace x by 1 by, it's here, minus 2 plus 1 e to the minus 1 equal minus e to the minus 1, which is negative. So here I put negative, positive. So always check by a number. Now, f of 0, if we replace x by 0 here, 2 times 0, 0, plus 1, 1, e to the 0 is 1. So f of 0 is 1. F of 0 is 1. F of half, by using the calculator, is 2e to the minus half, which is 1.2. I put 1.2 as the maximum. As x tends to plus infinity, y tends to 0. Here we have a horizontal asymptote. So this is the table of variation, increasing from the 0.01 to the maximum. Then we will go near to the horizontal asymptote. Part 4. Calculate to the nearest 10 minus 2. To the nearest 10 minus 2 means I need 2 digits after the decimal. 10 to the minus 2, only 2 digits after the decimal. Calculate f of 2, f of 3. They are particular points that help to solve, to draw the curve, f of 2 and f of 3. So part 4, f of 2 by using the calculator is 0.67. Only I take 2 digits after the decimal because he said to the nearest 10 minus 2. Yani 2 digits after the decimal. F of 3 equals 0.34. Part 5, draw C. We have to draw C. So part 5, draw C. We have x equal to 0 is a horizontal asymptote. We put dotted lines here. Either x equal to 0 or the y-axis. Now we have the maximum is half 1.2. This is half. This is 1.2. This is the maximum point. The curve starts from the point 0,1. This is the point 0,1. This is 1. And we get two particular points here. F of 2 is 0.67. This point is 2, 0.67. And the other point is 3, 0.34. 3, 0.34. The second particular point. Now, the curve is increasing from 0,1 to the maximum. Then it decreases near the horizontal asymptote, which is the x-axis. Now, part B, the demand, the economical part. The demand function of a certain article is modeled in thousands of articles. It is in thousands of articles. The demand in thousands of articles. Thousands of articles by fx equal to x plus 1 e to the minus x. This is the demand. Well, x is the price of an article expressed in thousands of Lebanese lira. So the price is in thousands and the demand is in thousands of articles. Part 1. Determine the demand. Determine the demand. We are going to calculate the demand if the price is 3,000. Demand, we need to calculate the fx when if the price is 3,000. Pay attention كمان هون to the domain of x. x is between 0.5 and 10. يعني ما فينا نحط محل x 3,000. Pay attention. So part 1. Price is 3,000. X equal 3,000 over 1,000. Why 1,000? Because the unit price is 1,000. 3 zeros with the 3 zeros, we get 3. F of 3 equal 0.348 thousandths of articles. So we have to say always for a price of 3,000 Lebanese lira, the demand is 348 articles. Always you have to mention this statement. Part 2. Determine the elasticity of the demand in terms of the price. The rule for elasticity is Ex equals minus x times f prime x over fx. So fx is given. F prime x is given here, f prime. So simply we replace each one by its value and we get the elasticity. So part 2 is about elasticity. So elasticity equal minus x times f prime x over fx equal minus x. The f prime is calculated in part A. It is minus 2x plus 1 times e to the minus x. The fx is given 2x plus 1 into e to the minus x. Now we can simplify e to the minus x, e to the minus x. Since it is in the form of a product, we can simplify. Minus 2x times minus 2x equal to x squared minus x over 2x plus 1. This is the elasticity. 2x squared minus x over 2x plus 1. Part 3, is the demand elastic for x equal to? Justify your answer. For the demand to be elastic, if we replace x by 2, if we get an answer greater than 1, it is elastic. Less than 1, it is inelastic. Equal 1, I call it unit elasticity. So we are going to calculate E of 2. Give also an economical interpretation of the value thus found. Give an economical interpretation of the value thus found. So, part 3, E of 2, we replace x by 2. We get 2 squared is 4 times 2 is 8 minus 2. 2 times 2, 4 plus 1, 5. 6 over 5, we get 1.2. 1.2 is greater than 1, so the demand is elastic. So the demand is elastic for a price of, the demand is elastic for a price of 2,000 Lebanese lira. Means if the price increases by 1%, always we say this statement, if the price increases by 1%, the demand will decrease by, how much this value? 1.2 by 1.2%. This is the economical interpretation. If the price increases by 1%, the demand will decrease by 1.2%. Finally, part 4. The management of this factory produces this article. Notices that the supply is modeled by hx equal 3x minus 1 into e to the minus x. This is the supply. Well, x is between 0.5 and 10. It is the same here. It is the same as here. Okay. Now, the management wants to stock a certain quantity in advance for the high season. What are the prices? What are the prices to fulfill the condition hx greater than fx? Hx greater than fx. So to solve hx greater than fx, we replace, this is the value of hx, 3x minus 1. Hx is 3x minus 1, yes. 3x minus 1 into e to the minus x greater than 2x plus 1 e to the minus x. We can skip e to the minus x with e to the minus x. So 3x minus 1 greater than 2x plus 1. X is to one side. 3x minus 2x. It's here 3x minus 2x is x. Minus 1 نجيبها لهون بتصير 1. We get 2. So x greater than 2. But pay attention to the domain. X belongs to domain of definition 0.510. X belongs to 0.510. Domain is 0.510. So x greater than 2, at 10 it is closed, okay. At 0.5 it is closed, so it is closed at 0.5 with 10 closed. So here we have x greater than 2. So it is required here to calculate what are the prices. So the prices, x greater than 2, but x should be less than 10. So the prices are between 2 and 10 thousands of Lebanese lira. So between 2,000 and 10,000 Lebanese lira. Okay, this is all for this exercise. For tomorrow, please prepare 2009, the first chance.